Okay, Algebra 1, Lesson 97, page 405. This is a lot easier than it sounds. Angles and triangles, Pythagorean theorem, and Pythagorean triples. All right. Y'all know what the Pythagorean theorem is. A squared, b squared, c squared. This is to find the hypotenuse on a right triangle or to find a leg on a right triangle. This is a right triangle. These are the legs. This is the hypotenuse. The hypotenuse is always across from the 90. Okay? Technically, this is A, B, and C, but it doesn't matter. Please don't get confused. If they call this C and call this A and call this B, this is still the hypotenuse. I don't care if it's called A or not. It's still the hypotenuse. This number is going to go right here. Okay, don't let that get confusing with you. The hypotenuse is always the hypotenuse no matter what letter they put on it. Okay, so the way this would work would be 4 squared plus 3 squared equals 5 squared. 4 squared is 16. That's a 6 plus 9. 16 plus 9 is 25. 25. This is a right triangle. 3, 4, and 5. These three numbers are a Pythagorean triple. That means that I put these three numbers on my triangle, it is a right triangle, and it will work. That's all a Pythagorean triple is. They're going to ask you for some Pythagorean triples. Just look at them. 97.1, there's A is going to be 3, 3, 4, 5. Okay, you come over to 97.2. You got 4 and 5. 4 here, 5 here. 4 squared is 16. Wow, I can't even write. 4 squared plus 5 squared equals c squared. Let's do it right here. 16 plus 25. I don't even know what that says. 25 plus 16. That's, oh, I can't even think. Did I do that right? 4 squared is 16. 6 and 5 is 11. Carry the 1. That's 41, right? So this number here is radical 41. There is no perfect square to that. That's just what it is, all right? Does that make sense? Now, this is not a Pythagorean triple because we don't want to use a radical, okay? Pythagorean triples are going to be whole numbers. But this is what that is, okay? Let's look at a couple others. We'll run them real quick here. Oh, sorry about that. They have it upside down. Don't let that confuse you. Let's see, what do we got? K and 5. Dude, that's what some class you guys in. That's this. I like Elijah, Tucker, Grant, K5. All right, and radical 61. That was an insult. Did you like that? Now watch. This is right here, and these two over here somewhere. So we have k squared plus 5 squared equals radical 61 squared. Y'all good with this here? I'm going to work it and move this over here. K squared equals the square root of the square of the square root of 61 is 61. I'm going to square this and subtract it over here. Minus 25. 61 minus 25. I can't do this. That's 36, all right? So k squared equals 36. K equals 6. So this number is 6. 6, 5, radical 61. All right? Again, not a Pythagorean triple because they're not whole numbers. All right? Doesn't matter where the chips fly. You just have to do what they ask you to do. They've got another one here, 12 and 8. I'm going to do it this way because I just get tired of it. Let's see. That's 12 on long side, 8, C. 12 squared is 144 plus 64. That's 8. That's 2. So this here is the square root of 208. Now, you always got to check this, okay? Can I pull anything out of that? Well, I can see that 4 goes in here, yes? Radical 4, 4 goes into 20 5 times, 52. All right. 52, I think I can do that one too. If that should be divisible by 4, let's just see. So I have the square root of 4 and the square root of 4. 4 goes in here once with 1 left over. So that's 1d3. So the square root of 4 is 2, 2, 13, 4 radical 13. Don't forget to simplify. This is not right. This is right, but it's not finished. If you leave that, I'll do the thing, mark it wrong, and put an equal sign. Okay? You gotta simplify. Now, just look at this next little section here real quick. What they're doing here is they're going to give you some Pythagorean triples. They're not asking you to do anything or anything else, just to recognize them. 3, 4, 5. Okay? Let's see. There's 5, 12, 13. 5, 12, 13. There's an 8, 15, 17. Okay? Those are just some common Pythagorean triples. 6, 8, 10. All right. In other classes later on in life, they'll do stuff with this, but like for practice C and D, they're just going to ask you to look back on there, fill in the number, see what it is. It's not that hard. You can solve for it and get it if you want. It's not that hard to do. Just remember to simplify your radicals. On the Pythagorean triples, it's just the ones that work with whole numbers.